lecture number 4 we will deal about equation of first order and first order degree. So what is equation of first order first order degree? So there are two standard form. There are two standard form of differential equation of first order and first degree. So what are their types? dy by dx equal to fx and y. So if you get a function in dy by dx, I basically mean differential equation in the form of fx and xy. So this is a first type. This is also known as first order first degree. And another type is you may get fxy dx plus nxy dy. This is another type of a differential equation of first order and first degree. So you should not worry, we will deal about this topic in later section, but in this lecture video we will concern only these terms, okay, these types of equation dy by dx equal to y. So let how we can solve differential equation of first order degree. So there are some methods how to solve. So this question you should ask ourselves, how to solve the equation of first order and first degree. So there are some methods. There are some methods to solve first order and first degree. So in this video, lecture number 4, we will only restrict to ourselves. We will try to solve such type of differential equations using method of separation of variables. So in separation of variable, we will separate variables in two sides of the equation, just like if you want to know how we do this. So in this method we will try to get all x and dx in one side and y and dy to other sides. So basically in separation of variable, we will try to separate x and dx term in one side of equation and y into dy related terms into other side of equations. So by this method we can separate variables. So and after separating variable you need to follow some steps that with these steps to get solution. So our first step is let arrange this equation in the form of a dy by dx. If you have a given f1x, f2y. So basically here you have given two functions f1x and f2y. So first you write this in the form, if you ask this question, if you given a differential equation in this form. So after that try to separate variables. using separation of variable method. So how we can separate? If you have a given equation in this form, so how will you do? Dy upon, you can separate, you have to separate dy into y into dy term in other side and x into dx terms on the other side. So how can you separate? You can put dy upon d2 f2y. If you separate left side to right side, so it will come to denominator, and f1x you can write dx. So in this manner you can separate variables, and after separating variable in step 3, integrate both side. So how will you do? Just integrate dy upon f2y equal to f1x dx, and this is the constant of integration. Okay, constant of integration. So this step, here step is mentioned. So if you follow this step and simply by following this step, simply you will able to solve the given differential equation of a first order in a first degree. So finally you will get a general solution if you were given some certain conditions. So by putting certain condition, you will get the value of c, and lastly you will able to get a particular solution of a given differential equation. So our next I am giving you some important relation. It will help you. It will help you in compacting your solutions. It will help you, and by using this relation identity, we will be able to compact your differential equations. I mean, you will compact your solution. Okay, so some important formula, like first we know that you can use log x plus log y equal to log xy positive, means you should always let x and y is positive terms. And our second relation, we can write log x minus log y equal to log x upon y. Please aware, here x and y is greater than positive because the log function should be exist. And our third relation, you can use n log x. These are the identities. Okay, you should aware about that. Log x to the power n, you can write. And our fourth identity is tan inverse x plus tan inverse y equal to, you can write tan inverse x plus y and 1 minus xy. And our fifth identity is tan inverse x minus tan inverse y equal to tan inverse x minus y upon 1 plus xy. And our last six identity number 6 is e to the power log fx equal to fx. So these are the some important identities. You should keep in mind that if you are able, you can memorize these identities, because it help you in compacting form. It will help you in write the compact form of equations. I mean, whether you will get solutions. So you can, using this, you can write a compact form of a solution. So these are the theory part, and now we will try to solve some problems. So I have taken first problems. Find the curve passing through 0 1 and satisfied dy by dx equal to c. So here question is asking you need to find curve passing through 0 1 where you will get the equation of a curve. So that equation will pass through 0 and also it satisfied sin dy by dx equal to c. So let how we solve this equation. So just you need to follow simple step. So you should not worry about that. So you have a given sin dy by dx equal to c. So you can rewrite this equation in the form of a if you write dyx equal to sin inverse, you can write this equation in this form. So next step, you are finally able to write given equation into dy by dx equal to form something from fx1 fxy, but here x is extremely not given, so you can you have finally able to write dy by dx equal to sin inverse. So next step is you have to apply separation method. So apply हल्ला मत करो. So dy equal to you can write dx sin inverse a. We just apply separation variables, rearrange this. If we arrange dy equal to sin inverse a into dx. Now integrate this. So after applying separation variable, your next step should be just integrate this. So if you integrating this term, you will get y, and if you integrate this term, so this is the constant term, so it constant will come out and you will get x, and this is our constant of integration. Please don't confuse, this is our c which is given in your equation, and this is the constant of integration. So our general solution is y equal to sin inverse c into x plus c bar. So finally, but in questions, okay, in question what is given, this curve is passing through 0 1. So according to question, curve is passing through 0 1. So it means so here curve is passing through 0 1, it means it will satisfy general equation. So put this point in solution equation. So we will get 1 if we put value 0 into sin inverse c plus c bar. So finally we will get c bar equal to 1. So our required solution is y equal to sin inverse c into x plus 1. So this is our particular solution of a problem. So next problem number 2 is solve dy by dx equal to e to the power x plus y plus x square e to the power x3 plus y. So this is a simple question. You just need to, you have to follow steps. So you do not have to do first step because here it is already given, but you can arrange this. Okay, you can arrange this in the form. So you can write e to the power x into e to the power y plus x square e to the power x3 into e to the power y. You can write this. After you can also, if you arrange this taking common e to the power y, you can write e to the power x plus x square e to the power x3. So apply separation of variables. Apply separation of variables. What you can do, you can shift dy upon e to the power y equal to e to the power x plus x square e to the power x3 into dx. Now integrate on both sides. So you will get uh, but you will get e to the power minus y dy equal to e to the power x plus x square e to the power x3 dx, and this is our constant of integration. And you can write also e to the power y dy equal to e to the power x dx plus x square e to the power x3 dx plus c. So in our right hand side we will get minus e to the power minus y plus, and for right side just write down like that. And if you solve this equation, this integration part, what you can do, put x3 equal to t. So what you will get, 3x square dx equal to dt, and x square dx equal to, you can write dt upon 3. So you can write, you can solve this, write x square dx equal to dt upon 3 and e to the power x3 equal to t, and you can write dt upon 3. So finally you will able to write, get 1 power 3 e to the power t, and if you put x equal to 3, so you will able to 1 upon 3 e to the power x3. So basically what we will get, minus e to the power minus y equal to e to the power x plus e to the power x3 upon 3 plus c. This is our required general solution of differential equation of first order first degree. Okay, so in this manner you can solve differential equation of a first order and first degree with the help of a separation of variable. This lecture video say I am stopping here, and if you have any query and you want to give some suggestion, just comment on in comment box. And thank you for watching this video. Thank you.